Hello everyone, welcome to lesson 8-5, volume of pyramids. We will continue to address how measurements help us describe the real world objects, and for our vocabulary we're going to look at lateral face. Real world link. Sand sculpture. Dion is helping his mother build a sand sculpture at the beach in the shape of a pyramid. The square pyramid has a base with a length and width of 12 inches. So we have 12 inches by 12 inches. It's a square pyramid, right? The base is square. And a height of 14 inches. Our height, notice that is measured exactly from the middle. We do not use these edges to measure height because it is skewed. It's not going to the height of it. It's slanted, so it's longer because it's going from this vertices all the way to the middle vertice. So we do not use the edges. We measure directly from the center of the base, directly up. Label the dimensions of the sand sculpture on the square pyramid below. So we have 12 by 12 and a height of 14. Question 2. What is the area of the base of the pyramid? The area, okay, is this square at the bottom, the base. So we use our formula for area equals length times width. We're only looking for two dimensions. Replace our variables. Area equals 12 times 12, as you see. And our area equals 144 inches squared. Question 3. What is the volume of a square prism with the same dimensions as the pyramid? So let's not pretend that all these edges meet at this top vertice. Okay, let's pretend that this, they all go straight up. Okay, and this is a square prism, a square prism. That means that once we have our area, we would have to multiply it, okay, the base of the area by the height, right? And we already know, okay, we have our volume equals length times width times height, and we already know our length times width, right? We established that that was 144. So it's 144 times our height, and we know that our height is 14, correct? That's for our volume. So 144 times 14 is 2016 inches cubed. The volume of the square prism is 2016 cubed inches. But keep in mind, it's a square prism. We did not actually find the pyramid, this shape right here. We did not find the pyramid. That's what we're going to learn now. Volume of a pyramid. The volume V of a pyramid is 1/3 the area of the base times the height of the pyramid. So 1/3, everybody. So the volume of this pyramid here, when the base is triangular, it's going to be 1/3 of, let's say, if it were an entire rectangular prism. So it looks like this. We have our volume is 1/3 of the base. Now remember, how do we get this base? Well, this base is capital B, is the area of our triangle times the height, times this height you see right here. And how do we get this height? Well, you can see that we get it from the vertex where all of these faces meet, and we go directly down to the center of our base. In a polyhedron, any face that is not a base is called a lateral face. So these are lateral faces. That's not because we're not using them as our base. We're using the chosen bottom one as our base. The lateral faces of a pyramid meet at a common vertex. Yep, they do, right there. The height of a pyramid is the distance from the vertex perpendicular to the base. The distance from the vertex perpendicular to the base. Okay, here we have a pyramid with our dimensions. right? And our pyramid, it's a pyramid because it kind of looks like the pyramids of Egypt, where we have a base, okay? This is a rectangular base, and triangles for the sides, where they all meet in one vertex. You can see that we have our length times our width. When we multiply our length times our width, we're going to get the area of the base, which we call the capital B, right? And then when we multiply that area times the height, we get the volume. But it's going to give us the volume of this entire rectangular prism. Okay, like this. No, I didn't do that right. More like this. I just had to erase this corner right here. It will look more like this, okay? If we just simply multiply the length times the width times the height. So 3.2 times 1.4 times 2.8 will give us the volume of this entire area. But we don't want this entire area. We simply want the pyramid. And this is why we need 1/3 of this entire rectangular prism. We only want 1/3. So you could essentially multiply these three numbers together and then divide it by 3. Then you divide it all by 3. So all over 3. This will give you 1/3. Or remember, when you multiply a number times a fraction, you get the fraction of that number. So you could multiply it also by 1/3. Multiply the whole thing by 1/3. And this is where we get our formula. Volume equals 1/3 of the area of the base times the height. Notice that the area of the base is the capital B. It's 3.2 times 1.4. And if you look here, we have 3.2 times 1.4. Correct? And then times the height, times 2.8. It's going to equal 4.2. Therefore, the volume is about 2.4 cubic inches. Now we have a triangular pyramid, which means the base is a triangle and it's still a pyramid because the sides meet at one vertex. And you see it's still a pyramid, but the base is a triangle. So we have to solve for the capital B, right? Which is our base, and we have to find this area. This area, you have to use the formula for area of a triangle. So it's half the base times the height. This is a nice even number, so I can half this one. This can be my base. Half of this, well, half of 6 is 3, and half of 4 is 2. And there we go. I can simply multiply these two numbers together, 8.1 times 3.2, and it will give me the value of my base of the area. Once I have that, the product of these two numbers, I multiply it by 11, and then I have to divide it by 3, or simply multiply it all by 1/3. Lots of steps to remember, everybody. But you can see it is still the same formula. Volume equals 1/3 of the base of your area times the height. Volume equals 1/3. How do we get the base of the area? We use the formula for a triangle, area of a triangle, because it is a triangle base. 8.1 times 6.4 times a half. Now remember, half, you can multiply this times this number or this number, use commutative property of multiplication, and get a half of one of them. And that's what I normally do. So I will multiply the half times the number that's easily divisible by 2, which is 6.4, as I did here. You see? I just cut it in half. Then you will multiply by the height. Once you do that, your volume is 95.04, and that volume is about 95 cubic meters. If you were to round it, right, you can get rid of this 400th because it will not change your tenths. Okay, here we have our question. Find the volume of a pyramid that has a height of 9 centimeters and a rectangular base. So now we know how to find the area of the base because it's rectangular. So we know how to use length times width, with a length of 7 centimeters and a width of 3 centimeters. Let's draw it. You should have something that looks like this. Remember, a length of 7 centimeters, there it is. A width of 3 centimeters, okay? And then a height of 9 centimeters. There's my height, and it goes to the center of my base, perpendicular to the vertex, okay? And for my formula for volume is volume equals 1/3 of the area of my base times the height. Let's replace the variables. So to get the area of my base, I have to multiply 7 times 3. 7 times 3, length times width, correct? And 7 times 3 equals 21. Now I have to multiply 21 times 9. Or I could do 21 times 1/3 first. Now we just simply have all multiplication, correct? So I could do commutative. If I do 1/3 of 21, it's easy because 21 can break into threes. You see, it's 7. So I will do that. 1/3 times 21 is 7. So what's 1/3 of 21? Divide 21 by 3 and you get 7. Times 9. Or remainder 9 right there. And 7 times 9 equals 63. So we have 63 centimeters cubed. Find the height of a pyramid. Now we're going to look at pyramids where the height is not given and we have to solve for it. You can also use the formula for the volume of a pyramid to find the missing height. Now we have to recall our lesson in equations. Notice that we are being given the volume. The rectangular pyramid shown has a volume of 90 cubic inches. Find the height. We use our formula as we know it. Volume equals 1/3 of the area of the base times the height. And we replace all the variables. Notice that this time we're not looking for the volume. The volume has been given to us. So we simply insert the volume. Insert the variables that have been given to us, such as the length times the width, which is what we'll use to find the base of the height. You see, the length times the width times the height. We solve, okay, we multiply, and when we have 9 times 5, we get 45. And then what's 1/3 of 45? Well, 45 divided into 3 parts is 15. So we have 15h. 15h equals 90. Here we have a one-step equation. What operation do we have on this side? Multiplication. What's the opposite of multiplication? Division. And that's how we're going to get rid of the 15 in order to isolate the variable h. So let's remove the 15 by dividing it on both sides, or simply by isolating the variable and inverting the operation and taking that 15 to the other side and dividing it on the other side, as we've done in class. So when you do that, it gets rid of the 15 on this side, so you're left with h, and 90 divided by 15 is 6. The height of the pyramid is 6 inches. Notice we're not writing cubed or squared, because we're simply identifying one dimension, which is the height. And the same applies for a triangular pyramid. We have our triangular pyramid. The only thing that changes here is the area. When we find the area, you have to divide it by 2 or multiply it by a half. So the base of the area is 8 times 3, 8 times 3 times a half, or divided by 2. Okay. Again, we use our formula. Volume equals 1/3 of the base of the area times the height. What's our volume? Well, it says here, our triangular pyramid has a volume of 44 cubic meters. It has an 8-meter base and a 3-meter height. Find the height of the pyramid. So here we go. So we have 44 cubic meters as mentioned here, that's our volume, equals 1/3 of the base of the area. We know that this is how we find the area of a triangle. Multiply times h. When you multiply 8 times 3, you will get 32 divided by a half. Sorry, no, 8 times 3 is not 32, that's 8 times 4. 8 times 3 is 24. 8 times 3 is 24, times a half is 12. And then what's 1/3 of that? What's 1/3 of 12? It's 4. And there's 4. And we're left with the h right here. So it's 4h. So 4h equals 44. Divide out the 4 to isolate the h. So we're left just with the h. And whenever you do one side of the equation, you must do it to the other side. So 44 divided by 4 is 11. The height of the pyramid is 11 meters. Okay, now we can find the height to each shape. We have to find the height to a triangular pyramid, and find the height to a rectangular pyramid, you see? So, if you think you can do this on your own, please pause the video and try it, and then play it to see how I did it. Pause now. Question B. A triangular pyramid, so the base is a triangle, has a volume of 840 cubic inches. The triangular base has a base length of 20 inches and the height of 21 inches. Find the height of the pyramid. So this is what our pyramid essentially looks like. Our base is 20 by 21, as they mentioned up here on the top, 20 by 21 inches. And our entire volume has already been figured out, that is 840 inches cubed. We need to solve for the height. We use our formula. Volume is 1/3 of the base, area of the base times the height. Okay, let's replace our variables. And here's what I have so far. Okay, I have my 840, as mentioned up here, 840 cubic inches is my volume, times 1/3, I kept that the same. The base of my area is the formula for the area of a triangle, right? So it's half base times height, right? Or length times width, whatever you want to call it. And then my h. Now, notice that I'm going to multiply one of these two numbers by a half. Which one of these two numbers breaks up nicely into a half? The 20, right? So let's go ahead and do that. Let's just break this one into a half. And when I multiply 20 times a half, I get half of 20, which is 10. Now I have 10 times 21. And so I'm multiplying a number times base times 10. 21 times 10, you take the 0 and just add it to the 21, and you get 210. Right? 10 times 21 is just 210. Now, what is 1/3 of that? Well, it's really easy to find 1/3 of 21, right? 21 is divisible by 3. And what's one of them? Well, 3 times a number is 21. 3 times 7, right? So 21 divided by 3 is 7. But it's not 21, it's 210. So again, just add the 0. So it's 70. 1/3 of 210 is 70. Remember, if you don't remember how to do that, just simply put this over 1. Okay? Place your 210 over 1 and multiply across and then divide. So 1 times 210 is 210 and 3 times 1 is 3. So it would be 210 over 3, right? So that means you're just dividing 210 divided by 3. So that gives us 70 as mentioned, times the height is 840. Let's isolate the h by inverting the operation. Remember 70, when we have a coefficient with a variable, this is multiplication. What's the opposite of multiplication? Division. And that's how we're going to get rid of it. Divide the 70 from both sides. And you know that 70 over 70 gets rid of the 70, right? It's just 1. And there's 1h. I'm going to go ahead and write my answer up here. Okay. Where I have just h equals, right? 84 divided by 70. 84 divided by 70. I'm sorry, 840 divided by 7. is the same as 84 divided by 7? Well, 7 times a number is 84. 84 divided by 7 is 12. Because 7 times 10 is 70. 7 times 11, 77. 7 times 12 is 84. But it's not, it's going to be 84 divided by 7 is 12. Or 840 divided by 70 is 12. Go ahead and rewrite our 12 right there. So what is our height? Our height is 12 inches. Not cubed, not squared. It's simply one dimension, 12 inches. And for question C, we have a rectangular pyramid has a volume of 525 cubic feet. It has a base of 25 feet by 18 feet. Find the length. Okay, let's go right to writing the formula. Volume equals 1/3 of our area of the base times the height. Our volume is 525 feet, right? Times 1/3, and our area of a rectangle is length times width, so it's 25 times 18, 25 times 18, and we're looking for the height. Okay, let's solve. I know that 25 times 20 is 500, but it's not 20. I have to take 2 of those 25s away. So if I count backwards from 500 by 25s, I get, it would be 25 times 19 would be 475. Because remember, 25 times 20 is 500. Take away 25, it's 19 of them, right? And then 25 times 18 would be 450. So I get 450 there. Remember, boys and girls, you can always use a calculator. There's no need. I just like to model mental math, doing mental math. Because a lot of times you might not have a calculator handy. Okay, now we're looking for 1/3 of 450. Well, 450 looks like 45. And to make up 45 into 3 parts is 15 plus 15 plus 15, correct? 15, 30, 45. But it's not 15 because there's a 0. So it's 150. So 1/3 is 150 times h equals 525. How do we get rid of the 150 to isolate the h? Well, we divide it out on both sides. Now, on one side, it's going to be divided out entirely. So we have our height left. On this side, we can simplify this fraction. We know that they're both multiples of 25. I told you earlier that 25 times 20 would have been 500. Right? What about 25 times 21? Going up by 25. Right? Going up by one more 25. It would be 525, wouldn't it? So there's 21 of them here. And how many of them are here in 150? Well, let's count. If we have 21 on the top, on the bottom, there's 4 in 100 and 2 more in 50. So that would be 6. Right? So 21 over 6 is our answer. But that is an improper fraction. Let's finish our answer up here where we have more space. Where we have our height is what? How many 6's are in 21? 3, right? Because 6, 12, 18. So there's 3 of them. And what do we have left over from 18 to 21? 3, correct? We have 3 left over. Over 6? Yeah. And what is 3 over 6 if we were to simplify it? Isn't it a half? Right? 3 is half of 6. Or if you wanted to write it as a decimal, 3.5. 3.5 what? 3.5 feet. So it looks like it's not a very tall pyramid at all, especially when you have these very large length by the width, but not a very tall pyramid at all. Here is the guided practice. If you have any concerns, please go ahead and take a look at it and reflect back to the examples to make sure that you are comfortable with the content before we look at it in class. Okay, see you in class, everybody.